Artist's impression of Oumuamua. Illustration. ESA. Last October, astronomers detected the very first interstellar object, an asteroid dubbed Oumuamua. New research suggests this visitor from afar likely came from a binary star system, and that astronomers should be on the lookout for both interstellar asteroids and comets. Traveling at a mind-bending speed of 67,100 miles per hour, the equivalent of Mach 88 at sea level, the distinctly cigar-shaped Oumuamua zipped through our solar system in October 2017. The closest it came to Earth was 20.5 million miles, 33 million kilometers, and with its speed and extreme angle of entry, the object headed back towards interstellar space. Naturally, as the first interstellar object ever detected, Oumuamua, pronounced Oumuamua and meaning a messenger from afar arriving first, has been under intense scientific investigation. Scientists made sure it wasn't an alien spaceship, they determined its chemical composition, and even wondered if similar objects may have seeded Earth with extraterrestrial microbes in the past. The latest research, published this week in monthly notices of the Royal Astronomical Society, investigated the types of environments most likely to produce and fling such objects into interstellar space. Oumuamua, according to the new study, most likely originated in a binary star system, one reminiscent of Luke Skywalker's fictional homeworld of Tatooine. The star system where Oumuamua originated was very young, and still in the process of forming planets. Using computer models, University of Toronto Scarborough astronomer Alan Jackson tested the conditions under which celestial bodies such as asteroids and comets might be hurled by their host stars into the great unknown. Our own solar system tosses the odd object into interstellar space, but the bulk of these objects are comets that form far from Earth, and are only very loosely bound by the Sun's gravity. Every once in a while, an Oort cloud comet jostles free, embarking on its new life as a celestial orphan. But Oumuamua is not a comet, it's very much a solid chunk of rock, with no obvious traces of ice, gas, or a cometary tail. Jackson's analysis suggests the odds are slim that this interstellar visitor was ejected from a system featuring a single star, or even a binary system where the stars are located far apart and exerting weak gravitational forces between the two. Now, it's not impossible, it's just highly improbable. More realistically, Oumuamua was tossed from a hot, nascent binary star system still in its planet-making mode. The stars were likely big and heavy, and surrounded by lots of material, some of which managed to escape owing to the many gravitational perturbations caused by the two stars in close proximity to each other. We simulated 2,000 binary stars on a computer and put a small body in orbit around each binary, Jackson told Gizmodo. We then gradually moved the orbit of the small body closer to the binary. Previous studies have shown that when objects get too close to the central binary their orbits become unstable, but we showed that almost every time the result is that the small body is ejected from the system. Jackson then looked at the known population of binary stars, and showed that there are a lot of systems in the capable of flinging rocky objects into space. Around 4 in every 5 star systems feature 2 or more stellar objects. Importantly, this is conjecture, albeit conjecture informed by statistics and computer models. We don't actually know which type of star a star system produced Oumuamua, but this study paints a picture of a probable scenario. That said, it's interesting to note that binary systems are likely to toss both asteroids and comets into interstellar space in roughly equal proportions, according to this research. Astronomers should therefore be on the lookout for both types of objects, and not be surprised to find an interstellar comet with an active coma, in which the sun warms the object's gas and ice, creating a tail. Overall, however, lone stars like ours and binary systems should distribute more interstellar comets than asteroids. So how weird is it that the first interstellar object ever discovered is among the rarer kind? Pretty weird, but that's how science works sometimes. The next object to visit our solar system, based on probability, should be a comet. But as Oumuamua showed us, nothing is guaranteed. Monthly notices of the Royal Astronomical Society.